Hi guys, welcome to the episode 3 of the topic single motor branch circuit complete design calculations. So episode 1 we have already done the conductors, and for episode 2 we have also determined the overcurrent protection or short circuit and ground fault protection. So this episode will discuss about disconnecting means or isolator, controller, and equipment grounding conductor. And for overload protection, will follow in the next episode. So let us review our motor feeder and branch circuit. We have the motor, feeder conductors, short circuit and ground fault protection, branch circuit conductors, and equipment grounding conductor. So here we will determine the disconnecting means, equipment grounding conductor, and controller. Overload protection device will follow. So for disconnecting means, what are we going to determine? So number 1, we need to determine the ampere rating. And the ampere rating of disconnecting means is provided by the code rules. Probably the ampere frame, which is provided by product catalogs. The appropriate type of disconnecting means, which depends on the application. The type of enclosure, and this is given by the standards like the NEMA standard. Applicability to installation. So let us think and decide whether a disconnecting means is required in this kind of installation, so that you have to include in your design. Controller. So what are we going to determine? So we have to determine the capacity or rating of the controller. This is provided by the code rules. The type of starting, this depends on the application, whether your starting will be star delta or Y delta, or part winding, or primary resistance starting, or secondary resistance starting, or etc. Also, the type of enclosure for your controller, you have to decide, and it depends on the application. The applicability to installation. So is it applicable, or is it required to use a controller in this installation? For equipment grounding conductor, code rules. This is also discussed in my first video lecture episode. Equipment grounding and equipment grounding conductors. Size of equipment grounding conductors. So this is the code rule. It is mentioning copper or copper-clad aluminum equipment grounding conductors of the wire type shall not be smaller than shown in table 250.122. So for equipment grounding conductor, this is the table. This is the table 250.122. Minimum size equipment grounding conductor for grounding raceway and equipment. So we shall use this table. And for this motor application, we have 175 ampere trip for our circuit breaker or short circuit and ground fault protection. So from the table, 175 does not exceed 200 ampere. So we shall use this row. Therefore, our equipping grounding conductor is number 6 American Y gauge or 14 mm squared as the motor equipment grounding conductor. Note that whenever the short circuit and ground fault protection device is increased by recalculation, equipment grounding conductor must also be increased and checked from the table. This is obvious because the equipment grounding conductor is dependent on the rating of your overcurrent device or short circuit and ground fault protection. For disconnecting means ampere rating and trapping capacity, the code rule is the disconnecting means for motor circuits rated 1000 volts nominal or less shall have an ampere rating not less than 115% the full load current rating of the motor. So it is 115% as the factor. So calculating current for disconnecting means 66 ampere FLC times 1.15. The result is 75.9 ampere. This is the minimum value for disconnecting means or isolator. So disconnect switch, use 80 ampere 3-pole 100 ampere frame. Ampere frame you can find also in the product catalogs. So basing from the standard ampere rating for fuses and inverse time circuit breaker. So here we have a standard exactly of 80 ampere. However, we can use also 90, 100 up to 175 equivalent to our short circuit and ground fault protection because this value is minimum value. So we can use 80 ampere only because we are already complying with the code. For controller, code rules, rating, the controller shall have a rating specified in 430.83A unless otherwise permitted in 430.83B or C or as specified in D under conditions specified. So general horsepower rating, controllers other than inverse time circuit breakers and multi-case circuit switches shall have horsepower rating at the application voltage not lower than the horsepower rating of the motor. So the horsepower rating of the controller should not be lower than the horsepower of the motor. So it is based on the horsepower of the motor. Also mentioned here for small motors, stationary motors, and some other code rules if you want to read. Torque motors. So controller selection. Remember that we have converted 30 kilowatt and it comes out to be 40.2 horsepower. So therefore we can use 40 horsepower motor controller at a voltage of 380 or 400 volts. This is a minimum capacity. We can use more than 40 horsepower. But note that this controller doesn't consider the type of motor starting, the type of enclosure. Now let us see and the update of the circuit designs. So we have a motor, 30 kilowatt, 380 volts, 60 ampere, 3 phase, power factor 0.84. We have the feeder conductor. We have already calculated the conductor size. Also the equipment grounding conductor. Also the short circuit and ground fault protection. Also we have also calculated the disconnect switch or isolator and the controller. So what is remaining is the overload device range and the overload device setting. So it will be discussed in the next episode of this motor topic. So what's next? Lecture episode 4, and this is the final episode. We will determine the overload protection and its calculation. Thank you again for listening and thank you for watching. This is my channel, Einbert Electric. If you like my video episode, just click subscribe, and click the notification bell and select all, so you will not miss any of my succeeding video lecture episodes. Thank you again and God bless.